Advent of Code day 17, trick shot. So basically, I'm gonna launch this thing, and it's gonna start at position 0, 0, and it's gonna have some initial velocity, which I can choose arbitrarily, anything I want, and I'm gonna step through time. And at each step in time, I'm gonna increase the x position by x velocity. I'm gonna increase the y position by y velocity. Then I'm going to slow down the x velocity towards 0. So if it's like if it's -5, it goes to -4. If it's 7, it goes to 6. And then due to gravity, y is always going to go down by 1. So then I'm going to be given this target area to shoot for. And in this, so in the example, it's 2030. My puzzle example will be bigger, I'm guessing. And basically, I have to try to shoot, figure out which velocities land in the target area. And so they show a bunch of examples. So like here, 7, 2 works. It goes forward 7, up 2, forward 6, up 1, forward 5, up 0, forward 4, down 1, forward 3, down 3, or down 2, forward 2, down 3, forward 1, down 4, and lands in the, so that's kind of how it flies. 6, 3 works as well. 9, 0 works. 17, 4, -4 does not. So it doesn't matter that it passes right through it. It has to stop in the area or be at the area on an integer position. And then it's asking, so once we want to do it in style, it says, so what's the highest y position we can reach on any trajectory that also lands in the area? So let's dive in. First thing we do is figure out how to parse the data. Let's go ahead and, so first, let's cat 17 example is that, 17 input is that. So in both cases, I'm gonna make some assumptions here. I'll get to that later. So first, we gotta figure out how to parse it. So we will do, it's not lines. Okay, Python 3 minus I, day 17 example, and so now we have this line. I thought we had this line. I need to save, I guess. Now we have this line, perfect. And we can get rid of, what if we split on space? It looks okay. Let's strip it because that RIP. That looks good. So now we can do line to get the x's. We need interesting if the y's go high then low. Do they do? Yeah, it goes high then low. Okay, fine. So the x's are going to be like that. 2. Yeah. Split on that. I wonder if I should have just split on that to begin with. No, I still needed something else. Okay. That. Sub 1. This is ugly. Text parsing here. What if I should split on comma to begin with? This is kind of silly. Like I'm sure if I was going for speed, what I'd do is just hard code in. I've just hard code these in because it's not like a lot of input to read. But I like my my things to look, I like my things to always take the input file and parse it. So we're gonna manage that. So this would be 6, 7, 8, 9, 10, 11, 12, 13. We can get rid of the x, 14, 15. We can get rid of the x2. So what if we do that? What do we get? That looks better. So if we do that, sub 0, split on that, and we can list map int that, and now we've got x min and x max. We will call this par equals I wonder if it's x min x, maybe it's capital, par x min tar x max equals that. Let's run that, make sure that worked. tx max 30. Beautiful. Okay. So now we just need to figure out a y1. We're going to start with line 15 strip, split on that. I'm guessing we're going to take 1 right there. And now we can split on equals. Take 1. And then we can do the same thing where we do list map int, which is just going to apply int to each of those things on, oop, I got to split that again. Split. How's that? There we go. So ty min, oh, actually, ty max, that does it backwards, ty min equals, and we'll put that in. Cool. Okay, so I'm sure there is some math we could do using physics to calculate velocities that land in here. But we're not gonna do that because that seems complicated and hard. We're gonna brute force. We're just gonna try that. I think it's gonna work in part 1. Who knows if it's gonna work in part 2? But to the brute force, what we're gonna do basically is, let's make this a little bigger. So we'll do for dx in range. Now my initial velocities, my initial x velocity has to be greater than 0. Because both my inputs have a target area that are greater than 0. So we're going to start, I don't want to start at 0 because if it's 0, it'll never get there. So I'll do 1, and then what's the maximum? This is a case where I could just throw arbitrary numbers in here and try it, but I want to really think this through because otherwise I could end up wasting a lot of time. So if the dx is larger than the maximum, than tx max, then it's going to shoot right through it on the first step and it's never going to get there. So we can stop effectively at tx max plus 1 because we if it's tx max and you know we could end up right there. So we want to make sure to get that. Okay. For dy in range, now y is harder because it could start off negative or positive. It can't be more negative than y min. So we can start at, could be, that's wrong, because, well, it depends on if we want to assume. Because we know, because we know that in both cases, the y min is negative, we're probably fine. But like if y min was 50, we could start off with y of 40 and go up, step up, or y of 25, for example, and hit it in 2 steps. So, okay, given what we know that our range is, we know y can't, or y min in both these cases. Ooh, I did not. I did this wrong. I'm now seeing. That's why it's good to check your input again. This actually is min. I've got that. Okay, good. Mins and max on negative numbers. Confusing. So we can do something like we can safely say negative 100 is fine, and then what we don't know is we could shoot way up. So let's do like 1,000. So then for this, what we're going to do is we're going to say x equals x comma y equals 0 comma 0 dx comma dy equals dx dy for t in range. Let's see. If x moved 1 every step, then it would be, t max. So let's just do tx max, which seems arbitrarily fine. We're going to do our steps. So x plus equals dx, y plus equals dy. Dx is going to move a step closer to 0. So we know we're always positive. So it's either going to go, but it's never going to go below 0. So it'll be max dx equals max 0 comma dx minus 1. Okay. dy is just going to minus equal 1. It's always going to get lower. So then we can do our check. If, let's see, so px min is less than or equal to x is less than or equal to px max, and py min less than or equal to y less than or equal to py max. We will, let's just start by printing xy document print dx dy, because that was our thing that got us there. What we're really looking for is the max. Go ahead and start this up here. Max y equals 0. Actually, we need to track that along each one. So we need max y equals 0. And up here we need max y. So down here we need max y equals max y and y. So we're gonna track. This is gonna be for each starting velocity. We'll track some max y, and then if we land in here, we will say max y equals max y and max y. Basically, we're going to track across the whole experiment. What's when we land in the area, is our new max y higher? Because if so, we want to keep it. This feels kind of aggressive, but we'll go for it. $45 is not too slow, surprisingly. 45 is our example. Let's give it a try. That. Can get rid of that. It's a little bit slower on the puzzle input, unsurprisingly. A lot more points are landing in, for sure, if we've done it right. There's some things we can do to speed this up, for example. I'm looking now. So, for example, we can break here, because we are done with that. Let's see if 4278 solves it. Yes, it did. Okay. Before I go to part 2, I'm going to do couple of checks here. Our x is always increasing or stopping. So we can know that if x is greater than tx max, so if x goes beyond tx max, we can break. We're done with this experiment. We haven't reached. Or let's see, if y goes below, so if y is less than py min, break as well, right? So if it's lower than the minimum, because y can never get, no, that's not right. If y is lower, I feel very happy with that one. What's my y coordinate? Because I could start below the thing. So I guess if dy is less than 0 and y is less than ty min, break. So that basically, if my velocity is going downwards, and it's never going to go up again, and I'm below the minimum, I can break out of it. Let's see, does that make it faster? And does that make it still right? That was way faster. So yeah, I like that. Okay. Okay, on to part 2. Fancy trick shot isn't the best idea. You only have one probe, so better not miss. To get a better idea of the options, you should find every initial velocity that causes the probe to be within the target area after any step. Okay. I think because if we'd done the math way, this would be way harder. Because we didn't do the math way. Let's see, points. Good equals that. And we will come down here, and anytime we land in here, we will do good dot append. What are we appending? dx. We can do it as a tuple because we're never going to mess with this. dx, comma, dy. And if we want to be really cocky here, we can just try to assume we're going to get it. F of part 2 len good. Did I write? Okay. Let's see. Good. The 112. 112. Okay. Try it on the puzzle input. 1994. Nice. All right, that was pretty fast today. Let's review. We can get rid of this print. Certainly not necessary. I'm pretty impressed with how fast that is. I think it's important. It would be worth showing just for a second. Some of these optimizations I put in. So, like for example, what if we took out? Let's do. Whoa. Control V down, capital I, put in the comment, escape, break. What if I took that out? And then what if instead of, let's see. Instead of doing Tmax, we just did like an arbitrarily large thing. So like we did 5,000 steps or something. Let's see. See, it takes way longer. So it would have been really tempting at the beginning to just like throw in like dx goes from 0 to 5,000, and dy goes from -1,000 to 1,000, and time goes through 5,000. But like clearly, like that costs us a ton of time, right? Even if we come back up here and let's put these brakes back in. See if that makes it much faster. Still having that T reign, that was better. That was better. I think either having a reasonable T. What happens if we put this? I should be running time on here. Let's see. Having a reasonable T makes it go way faster. Having a reasonable T, does having a reasonable T without these bounds still work okay? So no, even if those bounds are important, because even with a reasonable T, you can still. I'm guessing a lot of them are really. See, the next thing we'll do is we'll time. So that one took 17 seconds instead of a few. Versus if we put those in, if we put a long T in, but we put the brakes in whenever we get past it, I feel like this is gonna be pretty quick still. Maybe not. Yeah, still 7 seconds. So having both of those, having reasonable T and the checks in gets us down to a couple seconds, right? Yeah, well, that's less than 2. The other place I'm wondering if this was really smart was I started at 1 and not 0. What does that do to it? It takes it from 2 to... No, that didn't really hurt us. Okay, I thought that might have gotten us, but it's not too big a deal, so I can leave that for readability. Cool, so let's talk about what do we do? Sorry. So we got the input, we read the input in this really janky way. This is not at all readable, but it certainly worked. And you saw how, the way this is how I like to use the -I to really, just craft these things so that I can make them. If I was making this code for some sort of production environment, I would certainly handle it differently. Also, I would engineer the input to look less stupid. So, or not stupid, but, like less arbitrary text and things. If I could. So I'm going to start with my empty list of good points and my my 0 maximum height. Then I'm going to loop over this range of potential starting dx's and dy's. And I'm going to basically do the physics. And I'm going to track max y for each run. Initialize the physics. I then do the physics for each thing in the time step, keeping track of my max y. And if I land in the range, I have recorded my max y if it's bigger, my max y if it's bigger than the previous one. I append it to my good list and I break. Also, if I go beyond my range in either way, I can break, and then I print good. All in all, pretty simple. So maybe one of these days I'm interested to go read some write-ups and see how people did it with math, or if brute force was really the way. So anyway, thanks for sticking with me till the end, and I will talk to you next time.